So today we starting with ending off 7.5, 6 pages on combinations and permutations. Does anyone know what the definition of the difference between a combination and a permutation? Correct. Combinations order doesn't matter. Good. And permutation has order. It's all about sequences. Okay. So we're going to have here, it's a weird looking, who's seen that before? NCR? Who's seen that before? Okay. What does it mean? It simply means how many combinations of things you can choose from. How many things are you choosing from the group and without any order involved, as Tim and Rita was talking about. This is related to Pascal's triangle, by the way, and we'll get to that in a second. For example, who eats fruit? How many possible combinations of picking two fruits? You got a fruit bowl. There's 4 fruits in there. One's an apple, banana. Technically, banana's not a fruit. Does anyone know what banana is? It's a herb. Yes, correct, Emily. Banana is a herb. Cherry, and then date. Does anyone have an answer? How many possible combinations, if you went up to this fruit bowl, that you differently? Someone say 16. Anyone else? Okay. There's a number of ways we can do this. First of all, we can simply write it out. Now, if I write it out, you can see there's 6 combinations. We're pairing apple. First one is apple with B, C, and D. Then we're going to starting off with the banana, but we're not going back to apple. We're going with B. Banana hasn't been with cherry. Banana hasn't been combined with date. And then we start off with C with D. Okay? 1, 2, 3, 4, 5, 6. It's like when you're dancing and you want to dance with everyone else once. Okay? Me dancing with Zaid is the same as Zaid dancing with me one time, but we don't count it twice. I'm not going to dance with Zaid twice. Okay? Because we just danced. Well, we'll dance in the octagon, Zaid. That's what I meant. Okay, using Pascal's triangle. Think about it. We can see we are looking at NCR. 4 fruits, 2 at a time. In Pascal's triangle, it's the same as the row and the column. I don't know how Pascal did this and how people connected it. It's just there in maths. But if you look at Pascal's triangle, we did this before. Look, it's the 4th row. Counting at 0, 1, 2, 3, 4. And it's the 2nd column, 0, 1, 2. Magically, 6 appears. Okay, so in your exam 2 or exam 1, and there's a probability question, don't have a calculator and you're looking at combinations, all you need to know is Pascal's triangle. But let's calculate this differently. Your calculators, get your scientific calculator out, please. I'm not going to show it on the screen. I'm just going to show the buttons. It might be different to you. Can everyone find NCR on your calculator? You must punch in the number 4. If NCR were shift division is it in the same place as your calculator? This is not the class pad yet, but your scientific. The green one. Have a look at your green one. Have a look at your green one. Where is NCR? Where is NCR? Hey, yeah, it gives you the answer. K equals 2. Anyone else?
Wait,
Oh, yeah.
wait, so what?
My calculator is bigger.
So,
Like 8.
Oh, yeah, look at that.
that's the wrong
Wait, I don't get what
You have to do the calculator to me. Sorry. So as long as you guys found
Just do it like this.
Have you found it? How do you want to do it?
I don't.
Oh, maybe more on side. I think you can 4.
Try and go to
Probably.
Yeah, exactly.
Yeah.
Especially when internet access.
Oh,
Yeah, that's not me.
Oh yeah.
So I'll suggest up to 4.
Yeah, my big
And then go back to 2. And then 2.
No.
That is 6. Okay.
I mean,
You change.
fine.
Good.
Wait.
Nice and
How many? 2? Or is it how many?
Yeah.
Yeah.
I
Oh,
wasn't sharing anything else I can do. It's in wrong column.
No, that's it. All right. So we've got that under your belt with the scientific calculator. Now, let's use the class pad. You need to go to the main screen, keyboard, toggle down NCR. Got to punch that in first. Then you've got to input it. 4. That's a comma. 2. Okay. It's up to you which calculator you want to use.
Hold down. And then you go to like scroll across. Is it in lines? Oh.
What we doing? Yeah. That's it. So punch that in. And 4 times 2. 4. Yes. Good. How we going, guys? Can't find it. So there's places where it goes. Can you NCR there?
In a normal calculator.
Yeah, this is like
You have a normal calculator.
Oh, very cool. Yeah.
Screw that. This is a normal
So,
calculator.
yeah, then click on that.
We did in the
And
same
then
format.
input. Oh, you already got it there? Click there.
But what's the point of this?
Comma 2.
What's the point of this? You've already got a calculator.
6.
Except you don't have
It's
it
another
in
spot.
While we're waiting, let's have a look through it.
Okay. Have a go then. Got it good. That, can I see yours?
Yeah.
Thanks for sending it out. You, Tim. Thank you. Dave, how we go? Good. Good. Thank you. All right, so that's how you calculate it on the calculator. Now, so there is an actual equation that we use, pen paper, to do it as well. Has anyone seen this before?
Yeah.
Okay, so we now know that if I'm doing 4C2, all my n's become 4 and all my r's become 2. And if you keep going, I'll do it really quick. Been writing too big. Yep.
Wait, what?
4 factorial is a 4 times 3 times 2 factorial. Now, really important, if you look for factorials that are there on the bottom, try and expose them up on the numerator so you can cancel out. Okay? 2 factorial, 2 factorial. 4 times 3 is divided by 2 factorial, which is 2 times 1, gets you 6. Okay? That's another way to do that. Okay? You can sort of tell what's happening here. Look carefully. These are the total number of combinations. But remember, what's the difference between combination and permutation? We don't count the order. That means we're removing repeats. So we're cutting, when you divide something, dividing a cake, you're getting rid of stuff. So when we divide, we're actually dividing any repeats from the 2. But this one here is a bit more tricky to explain. This one is saying 4 take away 2. That means we're not dealing with 4s and we're not dealing with 3s. So we're getting rid of choosing 3 or 4 things in a way. Whenever you see a division, that equation is getting rid of repeats.
4 factorial divided by 2 factorial.
Yes. Very good. And we're going to get that into a second, Tim. Okay? And which is this very second right now. So, technically speaking, if we've got permutations, are we going to have more outcomes or less outcomes?
More.
Why more?
The same like combinations can be different order.
The same combinations can be the different order. We count them twice. Good, Nathan. Okay, so here, let's get the language involved. The number of permutations in the same way, sequences, of how many items we're grabbing from. We're taking a certain amount of items at a time, but we're thinking about order. Let's do the same application with our fruits. How many possible permutations of 2 fruits from the set of 4 fruits? Apple, banana, cherry, date. We can answer this question really quickly. If there were 6 combinations, how many permutations? 12. Because we're going to read every combination twice. What does that mean? Sequence matters now. I can have an apple, I can eat the apple, then I can choose to have a banana. That's order. Another time, I might feel like I want the banana first and then the apple. For me, my lunch is basically, most of the day, I have a banana and a muesli bar at recess and a banana and muesli bar at lunchtime. Pretty boring stuff. Okay. The reason why I choose that is simply because it's nice and quick. And we have no time, really, to do anything but prepare for the class. You can see there, if you wrote it all out, you'd get 12. But let's go the quick way. Your green calculator, you should be able to do that now. Can you do that now with your green calculator? Not NCR and PR. Let's do that now. Show me your screen so I know what you're doing. Excellent. Good. That's okay. Can you do the calculator? You have it in your locker, isn't it? Why is it 11:22? Nathan. Good. Good.
see not for zero.
I can do.
Okay. There.
One,
Good.
two,
All right. Now punch it into your class pad, please.
It should be 12, right?
It should be 12. Practice on your class pad. Excellent. Thank you.
So, basic nine isn't one. Four isn't was, and then NPR. What is it? Like makes it, and then like getting to 24. It's other. When I do it, that can do it on an actually. And so yeah.
Class pad.
Actually,
Thank you. Always I'll suggest you class pad reset it.
something storing.
NPR on your class pad.
Good. Wasn't done.
See if that works.
Because they have to be on reset.
No, there's a.
Oh yeah, now I've got this.
All right. Now you can see there's a slight difference, as Tim was alluding to before. Notice what's missing in the permutation equation that was in the combination equation. The repeats. We're counting repeats, so we don't want to cut them away. That's why we take it away out from the equation. You can see clearly, if we apply the formula, you'll get quite quickly a 4 factorial and a 2 factorial. 4 times 3 times 2 over 2 factorial. Factorials cancel. 12. Okay. Any questions? Next. Okay. My voice just broke. A team of 5 students is to be chosen from 6 boys and 5 girls. So, for example, an indoor soccer team, only 5 people allowed on the field. In this bigger team, there's about 2, 4, 6, 8, 10, roughly. 6 boys and 5 girls. Calculate how many teams can be formed. That's the question. Calculate how many teams can be formed. Okay, so we're combinations. Good, Amrita. We're looking at combinations. We're not looking at permutation. Sequence. A team. There's no sequence in team.
The girls don't look exactly the same.
Even twins aren't the same, Tim. So, Tim, what is our N, Amy? What's our N? What's the pool? It is 11. What's our R? How many are we choosing, Maya? What's our R? 5. Okay. As Amrita said, we are looking for combinations. So you use the big C. 5. Oh, whoops, mistake. 11. 5.
So it's quite big, huh?
It is a huge number. What'd you get? 462. Okay. If you punch that into your calculator, You'll get 462. Let's do it on paper.
Oh, that's good.
11 factorial.
Our.
R, what's R? 5 factorial. Yeah, you're going to get really used to this by repetition. You don't have to write down the formula all the time. Let's go for it.
What's it?
11 times... I'm going to stop at 6 factorial. Why?
Answers all that.
Because there's a 6 factorial on the bottom. I'm going to eliminate them. There's many ways you can do this. This is how I like to do it. 11 times 10, and then you could sort it out. 462. Okay? I'm not going to write that. I will write out the whole thing. Okay? To get your 462. Any questions? Gets a bit trickier, these questions.
No, it's either one to do the test, like that's too much.
All right. Calculate how many teams contain exactly 1 boy and 4 girls. 1 boy, 4 girls. What's your N? And what's your R? What's your N? What's your R?
Don't you have to do two sets?
2?
Right. 2 sets.
You do. Well done, Zach. Okay. So, Zach has picked up on something. You've got to do 2 things. You've got to look at the 1 boy that makes the team for that game. And then how many girls are we going to choose from? 4. 4 girls.
Out of 5.
4 out of 5. Okay. 1 boy. What are the 2 numbers going to be? 6. And we're choosing 1. Now, when we choose 6 and 1, on your Pascal's triangle, remember there are... Yeah, it's just 6.
Okay.
Whenever, as a quick reference, whenever there's a 1 there, whatever that number is there is the number of ways. What if it's a 0?
1.
1. Good. What if it's the same?
1.
Excellent. Good. Make notes of that because we're talking about the edges of the Pascal's triangle. Well, let's go back to the question. And this is 6. 4 girls. 4 girls, okay? What is our N? What's our R? 5 and 4. Punch that in your calculator or let's do it for real. See if you can beat me. 5. Can we, yeah, it's 5. Okay. Can you see that on a Pascal's triangle, what's 5C5?
1.
1. So therefore, backwards 1 is 5. If you picture the Pascal's triangle.
Yes.
If you can't, you do the equation. And then, or draw it. There is nothing wrong with that. But time is not on your side.
Yeah, I have one in my.
You'll have a, what does it say on the front? Yeah, with Cascade. No, I just copied it from the other one. You'll be able to use a case. Okay. Okay, so that's 5. If I open up the factorial, they're going to cancel out. Next question. Good. It's good to see people's minds ticking over this.
This could not be the hardest 20.
What do you want about that?
Yeah, because what's 7.6 like?
Oh, it's actually, we've touched on it before, 7.6. You guys will be able to get it. Possibly.
Do we need it?
Uh, you can just leave that question out until you know what to
How
do.
long? Done. Oh,
You just have to do the questions you can do. So,
this is warm.
did you get that, Gabe? Well, you're reading the notes, were you?
Yeah, it's just the amount of combinations where there's 4 girls and the amount of combinations where there's 1 guy.
Yeah.
Anymore.
Yeah, pretty much.
Exception.
Yeah. Let's see. Well, second last question. Calculate how many teams have at least 2 girls. Okay. So, if we want 2 girls, what combinations can we have? We've got 2 girls and 3 boys. Is that it?
At least 1 girl.
Uh,
Or how many? At least
2 girls?
3 girls.
3 girls.
3 girls.
4 girls.
And how many boys?
2.
4 girls.
4 and 1 and then 5 and 4.
Can I do? I've made a mistake in my notes. I didn't include 5 girls, so I'll change the question to suit out. Okay. Yeah.
Well, so yeah. Okay.
We're good.
Yeah.
I will change this question to say you need at least 2 girls and 1 boy. I hope that fixes our question. We'll see. Let's just go with these ones anyway. 2 girls, 3 boys. For the first one, what's my first seed for the girls, Nathan? 2 out of how many? 5. What about 3 boys? 3 from 6. Okay. 3 girls. 5 and 3. 2 boys. 6 and 2. Okay, you guys are getting it. Last one. 4 girls. 5 and 4. 6 and 1. Okay. And you get your calculator to punch them in. Okay. If you do your calculator right, you'll get these numbers. Yep, good. But remember, we're after a total. If you add them all up, there's 380 ways to do that. Last question. What are we swearing about? Last question. Calculate probability of the oldest and youngest students both being on the team. Okay. What's going on here? Close.
11 to 1.
Not quite. You're close though. This is the way to look at it. Oldest and youngest, no matter what we're talking about, we're knocking off 2 people. So it's added 9. Let's just say we chose the oldest, and then we chose the youngest. What does that leave us with over here? How many students can we choose from now? 9. N is 9, and we're choosing 3. So this is 9C3 for the last 3 spots. And these aren't really affecting because we're just reducing the group size. Now, what's the key word here that we're calculating? It's probability. So therefore, what did we already work out with what's this called again? Universe, that's really weird. Universal set.
No,
We worked out from before, we had, 300. It was actually 4. 462. Yep, good.
Yeah, he said that was one of the things we did, and it said 4 songs.
So, if I have 11C5 on the bottom, what goes in this space here in the numerator? If this is the universe, we simply 9C3 it on the top.
Oh, because that's the small amount of the total.
That's a small amount from the total. And the small amount is our event A. Our event is, this is the event.
Oh, so 84 over 462
And what did you get?
equals
2 out of 11?
Yeah.
2 out of 11. In the notes, I've done a whole calculation with the factorials. You can refer to that when we're done, and we're pretty much done. Okay. Any questions? Okay.